This is Chapter 5, Problem Set 3, Present and Future Value of Annuities. The present value of an ordinary annuity. You receive $500 per year at the end of each year for 10 years, and the appropriate interest rate is 15%. What is the present value? Well, the future value is set equal to 0, and we set the payment equal to 500. The interest rate is 15%, and the number of payments is 10. So we compute the present value, which will show up as a negative 2509.38, but we drop the negative. Present value of annuity due. You receive $500 per year at the beginning of each year for 10 years at 15%. Well, once again, we set it up and we compute the present value of 2509.38. But because it's an annuity due, we multiply the present value by 1.15, 1 plus the interest rate, to get the present value of getting the payments at the beginning of each year, which would make them $2885.79. The future value of an ordinary annuity. What is the future value of $600 deposited per year at the end of the year for 10 years at 9%? The present value is set equal to 0. Payment is $600. The interest rate is 9%, and n is equal to 10. We compute the future value, which will be $9,115.76. The present value of the same series of cash flows, but at the beginning of the year, will be an annuity due. So once again, we compute the future value of $91,115.76 for the future value of an ordinary annuity. But since this is an annuity due, we multiply it by 1 plus the interest rate, which would make it $9936.18. Finding the effective interest rate. So say you borrow $200,000 and repay it at the annual end of the year installments of $20,500 per year for 30 years. What interest rate are you being charged? Well, the present value we enter is a minus $200,000. The future value is equal to 0. The payment is $20,500 per year, and the number of years is 30. We compute IY, which turns out to be 9.59%. You start out with 0 and deposit $500 a month into an account, earning 7% per year. How many months will it take for you to have $1 million? The present value we set is equal to 0. The future value we set at 1 million. The interest rate we set at 7% divided by 12, because this is monthly deposits, for 0.58333% per month. We compute n, and this is 436.52 months, or 36.4 years.